Okay, so in the last session, we have discussed about numerical integration. Let us continue that part. So numerical integration means without knowing the function, actually the values taken by a function is known. From that, you have to get the value of that integral, that means integrand, without knowing the function. So numerically, we have to evaluate. So it is called numerical integration. Now, whenever it's asked to find the value of the integral by numerical method, what you have to do is first you have to see the interval where we need the integration. That means usually if it is asked to evaluate integral of f of x with respect to x from a to b, we shall take that this integral is called I. I means a finite value we need. Actual meaning of integration means finding the area under this curve. F of x means there is a function between two variables x and y. We shall take y is equal to f of x. That means for the independent value of x, there is a dependent value of y. The relation is given by y is equal to f of x. Integrating f of x from a to b means the meaning of integration is nothing but y is equal to f of x means it's a relation. Relation means we get a curve in the on the xy plane. So there is a curve. What is the area under this curve? Whatever the curve it may be, what is the area under this curve between these two ordinates? X is equal to a means a straight line parallel to y-axis. X is equal to b means another straight line parallel to y-axis at a distance b from y-axis. Between these two ordinates and this curve above x-axis, there is a region. Area of this region, it is given by this integral. So actually integration means finding the area under this curve. So this concept is used for numerical integration. And we divide this. So in this numerical integration process, what we do is we divide this interval AB into n equal subintervals. You have to note that n equal subintervals. When you divide this, we call this point of division by x, x1, x2, etc. And starting point, this one you take it as x naught. So it starts from a means let x naught be a. Then, since it is equal interval, you go on adding a constant to each division. So if you add h to a, you get a plus h. That you get take it as x1. So x naught is equal to a. X1 is x naught plus h. X2 is x naught plus 2h, or you can take it as x1 plus h. Continue like that. At the end, you can reach here. That is xn we call xn minus 1 plus h or x naught plus nh. We reach here. So by dividing this n equal parts, we make some subintervals. Integration of this one is equivalent to find the area of the curve, area under the curve. But when you divide this one into equal subintervals, we get small rectangles. We find the area of a rectangle using the formula length into breadth. So if we go on adding all this, that gives this much total area. So it's a geometrical meaning of that, but we shall leave all this part. We shall directly go to the formula, how you evaluate this integral. So first step is divide this one into an equal parts. But we have to note one thing. If you divide this interval into two equal parts, means one division is enough. So one division means, suppose that A to B there, one division means you get two intervals. That two intervals called, values are called ordinates. So two ordinates means one division. Similarly, two division means you get three ordinates. So three ordinates means two division. Or if the question is by taking ordinates means, meaning is that is 7 division. So number of ordinates is n means, number of ordinates n means the number of division is 1 less than that. So you divide this one n equal subintervals. Each one will be of length h. So you call this, name this by x naught, x1, etc. xn. Xn is nothing but x naught plus nh. We call it as last value. At each value of xi, you find the value of f of xi. You call it as yi. So yi means y1, y naught is the value of y at x naught. Y means f of x. When you put x is x1, it gives the value of f of x1. You call it as y1, like that. Let y1, y1, y0, y1, etc., yn be the values of y at equidistant values of x. Once these are known, depending on the number of divisions, we use some formula. So how it is derived is now not important. We just directly write this formula. So first we use, there are 4 or 5 different formulas given in the syllabus. So that let us see. The first one is called trapezoidal rule. Using this rule, how to get the value of the integral f of x from a to b. To get this integral, the formula to be used is that trapezoidal rule means you add all these values. There is first value of y and last value of y. That you write the first term, y naught plus y naught, y naught plus yn, plus 2 times all remaining suffixes. You multiply this by h by 2. This give the area under this curve using trapezoidal rule. But here number of division is not restricted. Whatever the number of division, you can use it. It may be 10 division, 5 division, 6 division, whatever the number of divisions, we get the answer, but need not be the exact answer. We get some approximate answer. It may be far away from the exact value. So there's one drawback of this trapezoidal rule. Now modification of this rule, it is called another one, that is called Simpson's one-third rule. So when the number of division is more and more, we get good answer. Here, if you take n is equal to 1, n means that is actually derived using interpolation formula. In that interpolation formula, if you take number of values given, that is n there. If n is equal to, depending on n, we write the formula here. When n is 1, you got trapezoidal rule. That is called general quadrature formula. Here in general quadrature formula, if you put n is equal to 1, it gives trapezoidal rule. If you put n is equal to 2, it gives Simpson's one-third rule. In this rule, the process is like this. To get this integral, h by 3 into first value plus last value, 2 times all even suffix of y outright, plus 4 times all odd suffix of y. Or shortly, you can write this formula as h by 3 into y naught plus y1 plus 2 times even plus 4 times odd. Even means only even suffix you have to consider. Odd means only odd suffix formula. So the odd suffix values. So you can easily remember this formula, Simpson's one-third rule. Again, better than this one, another formula is there. That's called, but to use this, the condition is the given interval must be divided into even number of equal subintervals. If it is even number of subdivision means you can use it, right? Otherwise, we can't use this. Suppose that divided into 9 division means we can't use this formula. So that you should know what is the condition where this method fails. Next, Simpson's 3 by 3 rule. That's another formula. Here, the formula goes like this. Instead of h by 3, you multiply by 3h by 8, as it named as 3 by 8 rule. That first and last, plus 2 times all multiple of 3 outright, y suffix 3, y suffix 6, etc., y suffix n minus 3. Because the condition to use this method is, it must be, this interval must be divided into subdivisions, which will be multiple of 3. So here 2 times all multiple of 3 you have to write together, plus 3 times all remaining suffixes. You add all this, multiply 3h by 8. This formula it is known as Simpson's 3 by 8 rule. And another formula that's given the syllabus is, and here the condition is the number of subdivisions must be multiple of 3. Another is Wedel's rule, but it goes in some other pattern. The formula is like this. To get this integral, 3h by